Welcome to another NanoBeacon config tool video tutorial. In this video, we'll be covering the topic of encryption and authentication and how NanoBeacon handles both. We'll also go over how to implement these and how to configure your application to utilize the encryption and authentication for your advertisement data. So let's get started. NanoBeacon supports simultaneous encryption and authentication of the advertisement data, and the implementation is based on the AES-EAX encryption algorithm, and it's detailed in this research paper displayed here. Now, the encryption and authentication can be configured and enabled independently for each of the advertisement sets. And you can also specify exactly which advertisement data fields are encrypted or not, with some restrictions, which we'll talk about later. The AES-EAX engine requires the user to define the following inputs. So there's the 16-byte key, which is used for both encryption and authentication. There's the plain text data, which in our case is the advertisement data that we want to encrypt. There's a 6-byte nonce, and nonce stands for a number used only once. And then there's the number of bytes for the authentication code, which is usually referred to as MAC or MAC, MIC, or simply the tag. The outputs of the AES-EAX engine are the encrypted data or ciphertext and the tag or the authentication code that we mentioned. Let's take a look at each of the inputs that we just went over. So in order to get to this, you choose the advertising set that you want to configure, because again, this is configured, the encryption and authentication settings are configured per advertising set. So you have to go into editing one of the advertisement sets. And then once you get in here, then you have to choose the custom data, go into settings, and then choose data encryption settings. So the first option is to choose the key, and you have three choices. You have key 0, key 1, and key 2. And those can be set by going to the keys menu under global settings. Here you can specify key 0, key 1, and key 2. And these keys can be utilized for advertising data encryption, authentication, as well as for creating a private resolvable Bluetooth address. And once you have the key defined, then you can navigate back to the data encryption settings within the advertisement set, and then choose the key that you want to use for the encryption. The 6-byte nonce is made up of two parts. There's what's called a salt, which is 2 bytes in length, and a 4-byte nonce counter. Now, the salt can either be a random generated number, which changes for each advertising interval, or a fixed number that you define here in this field. Now, if the salt is chosen to be random, then you will have to include it in the advertising data in order to relay this number and value to the receiver. In the case if it's fixed, then you don't have to include it, and you could have just the receiver know that upfront. For the nonce counter portion, you have three options available. You have the timestamp 1, which has a 1-second resolution and starts counting right upon boot up of the device. Then you have the advertisement count, which is individualized per advertising data set and is initialized to 0 upon boot up. And finally, you have a predefined number that you can define in this field. Now, normally the nonce counter is not included in the advertisement data. So for example, if you use timestamp 1 as the nonce counter, then the receivers may resolve the counter using the algorithm that we described in the research paper we mentioned. To make resolving the nonce counter on the receiving end easier, since it involves intensive computation, the user still does have the option to include that counter as part of the advertisement data. Now note that for whichever type of nonce counter you choose, you will need to make sure that it is included and chosen to be in big endian format in the advertisement data. And finally, if the receiver knows the nonce counter, such as in case of the predefined fixed number here, then you don't need to include it in the advertisement data. However, to achieve maximum security and privacy, it is recommended to use real-time varying numbers such as timestamp 1 and the advertising counter for the nonce counter. And the third input to the authentication or encryption engine is the number of bytes for the authentication code. And this can be defined in the area where you specify the data field that you want to include in the advertisement set. We'll take a look at that here shortly. But before we do that, let's cover one important aspect. The encryption data fields have to be included in consecutive order within the advertising packet. So for example, if we take a look at this, what's shown here, we see that data 1 is encrypted, and then data 2 is in plain text and not encrypted, and then data 3 is encrypted. So data 1 is separated from data 3, which both are encrypted, and this is not supported. They have to be in a continuous data block. So in order to accomplish this and be able to support this, you will have to include data 1 and data 2 and data 3 all to be encrypted for this use case, or you can swap out the location of data 3 and data 2 and then have data 1 and data 3 encrypted continuously and then have data 2 at the end unencrypted in plain text. So keep that in mind when determining which data fields are to be encrypted. So almost all types of data fields that we looked at previously, if we go back to, for example, using the manufacturer specific data, most of these data fields can be encrypted. So that's one way that you could use the encryption. So if I select VCC, I can choose to encrypt it or not. And in that case, it will use the key that was selected in the data encryption settings. This applies to most of the other types of data as well. You can choose to encrypt or store it in plain text and so on. And so now let's look at how we include the specific encryption and authentication related data fields in the advertisement data. So the first field we want to look at is timestamp 1. If you recall from previously, timestamp 1 was one of the choices for the 4-byte nonce counter. If we go to timestamp 1, you can see it's by default 4 bytes. So this field can either be used in a generic way where maybe you want to include the time since boot up in 1 second resolution for the receiver to find that out or to know about it, in which case we would encrypt it or not based on what we want. Or it could be included as representing the nonce counter, in which case it should not be encrypted since that really defeats the whole purpose. Though as we mentioned before, the receiver may resolve the timestamp 1 nonce counter using the algorithm described in the research paper that we referenced. Next, we want to look at the advertisement count. So if we look at ADV count here, this is another field that is related to encryption. As we saw earlier, the advertising count is another option that can be used as the nonce counter. So this can also be used either generically, whether it's encrypted or not, or as a way to relay the value to the receiver for decryption and authentication purposes, in which case it should not be encrypted in the advertisement data. Another field is the encrypt raw, and this one can be used to include an encrypted chunk of predefined data. As you can see here, we have the EAX salt, which is the 2-byte value that's defined in the encryption settings. Here we can't change the number of bytes because this is predefined in the encryption settings. And then we have the auth tag. In this case, the default length is 2 bytes, but the user is able to change it to whatever length they desire. So that's it in terms of the encryption and authentication settings. And in the next video, we'll be moving on to some more practical examples. So to help you set up advertising sets and capture them in a BLE scanner of your choice, we'll be going through that in the next upcoming video. Thank you for watching.